Okay, we are going to uh, continue chapter number 6, the link layer and the lens. So in last class we had discussed chapter number 5, ICMP and SNMP topics, and then we started uh, chapter number 6, and we discussed data link layer services and error detection and correction schemes. So in today's class, we are going to continue chapter number 6, and we will like to discuss some multiple access protocol. In particularly, we will discuss FDMA, TDMA, random access protocols, and taking turn protocols. And after discussing these multiple access protocol, we would also like to discuss ARP and Ethernet header if time permits. So we are going to start multiple access protocols. Multiple access protocol. As we know that we have discussed in chapter number 1, if you do remember, that there are two types of links. From functionality point of view, there are two types of links. One is called point to point, and another is called broadcast or shared medium. So point to point link, what does it mean? Point to point link means a link that connects only two nodes. This is called point to point. Point to point, a link that connects two nodes. A link that connects two nodes, it is called point to point. For example, the point to point protocol example is dial up access. From the home to your nearest pole, the PTCL or the PTCL line, it is the point to point link. Okay. So what is the problem? So in point to point, for example, if you want to connect 5 computers, so each computer is connected to each other computer directly. Okay, so this is point to point. So what is the advantage? The advantage is that if this link is full duplex, then each node can send simultaneously. Okay, that is, each node can send anytime to another nodes. Okay, for example, if this node is sending data to this node, so it will be using this link. If this node want to transmit to this node, it will be using to this link. So this node can transmit at same time to both this node to each and every node. So each and every node can transmit same time to all the nodes. So this is the advantage. However, the disadvantage is that when the number of nodes increase, so we need more number of links. Here, how many links are needed? For example, if we have 1, 2, 3, 4, 5, so 5 into 4, 5 into 4, 20, 20 into 3, 60, 60 into 2. So you can see that how many nodes are 5 4s are 20, 23s are for example, you can see that how many links are needed. 1, 2, 3, 4. 1, 2, 3, 4, 3. Each node is maintaining 4 links. So 1, 2, 3, 4, 5. So 5 4s are 20. Okay, so we need 20 links. Okay, so therefore, if the number of nodes are increased, then the number of links will be increasing. So this will becomes complex. Sometimes the point to point link is infeasible. Why? Because if one node is in Pakistan and another one is in the USA, so it is very difficult to lay down the physical link from Pakistan to USA. Okay, so therefore so we use the broadcast or shared medium. So what is mean by shared medium? For example, here one link is deployed, okay, and all the nodes, they are connected to the link. Okay, So this is the shared medium. This link or this medium, it is shared by each and every node. So what is its disadvantage? What is its advantage? The advantage is that uh, that here we need 20 links, but here we need just one link. So its cost will be reduced. But its disadvantage is that if one node use this link, then other node cannot use. That is, this link can be used at a time by only one node. Only one node can transmit the data, and the other nodes cannot transmit the data. Okay, so if other nodes wants to so therefore if because if one node is transmitting the data, then the other node cannot transmit. Why? Because this is a shared link. Okay, so if one node is transmitting the data on the link, so the other nodes cannot transmit at that time. Okay, so this is, so if other nodes transmit at the same time, so if two or more than two nodes they transmit at the same time, then both signal they will collide with each other, and when they collide with each other, this is called packet collision or signal collision. So in the case of packet collision, the both of the both signals are lost. Both signals are lost means that both data is lost. Okay, so therefore we need a certain mechanism that how these nodes they can share this medium, they can use this link, this shared medium, so that this collision is avoided. So in this type of shared link, the medium axis, the link axis, it is a challenge, because if one node, so we have to use certain mechanism that how this shared medium can be used by all the nodes. Okay, so definitely it's the advantage of shared medium is that we need we will need just one link. Okay, so how it is used? It was used in old fashioned Ethernet. Okay, it was also used in upstream HFC. We have already discussed it, and it is also used in 802.11 wireless LAN. It is used shared medium. So all these three technology, they are using shared medium or shared link, or it is also called broadcast link. Okay, for example, this is the wired Ethernet link, this is the wireless LAN, and this is the okay, the shared RF radio frequency in the satellite. Okay, so as I have already discussed, that the challenge in this network is that in the shared medium is that how this link should be used by the nodes. So how to coordinate? For example, if this analogy is like that, for example, if there is a people, so okay, so if two or more than two people they start speaking at same time, then no one can hear it. Okay, so the signal interfere with each other. So similarly, we need some kind of mechanism so that if one person is speaking, the other has to listen it carefully. Okay, so therefore we will discuss these mechanisms, okay, in the next slides. So if we want to use the single shared broadcast medium, if the single shared broadcast medium, it is used by more than one machines. Okay, so we need a multiple access protocol. Okay, so that if one node is transmitting, the other node should not transmit it, because if more than two nodes they transmit at the same time, then the collision will occur. Okay, so how the single shared broadcast channel can be shared, how this single shared medium can be used. Because if two or more than two simultaneous transmission by nodes, it will cause interference. If two or more than two nodes start to transmit the data, then it will lead to collision. Collision means that both signal will last. If node receives two or more signal at the same time, then the same signal at the same time, then it causes the collision. For example, if two or more than two persons start speaking, then the teacher will not understand. Okay, so this is similarly here, if two or more than two nodes transmit the data and the shared link, then it causes the interference. That is, both the signal it collide with each other, and both the signal they are lost. So we need some kind of multiple access protocol. Why? So that how this medium will be shared. That is, to allow that if one to make sure that if one node is sending the data, then other should not send the data. Okay. So for this purpose we have different kinds of protocol, but normally it is preferred to use the distributed algorithm to determine how nodes share the channel. Okay, so we will discuss about it, that the distributed algorithm it is better, but for certain scenario the centralized algorithm are also better. So okay, so we will discuss both the distributed algorithm and centralized algorithm in the next slides. So definitely, if to use this multiple access protocol, it ensure that if one node is transmitting the data, then other node should not transmit at the same time. So how to make it done? So for this purpose we use multiple access protocol. Okay, so the multiple access protocol, for their working, it is needed to exchange the data among these nodes. Okay, so for multiple access protocol to work, so the multiple access protocol they exchange the data among these nodes. So for this purpose we use the same channel, this same link, this same channel. It is used both for transmission of data, and it is also used by these nodes to talk for multiple access protocol. So for multiple access protocol means that these nodes they will share data with each other, and so that it will communicate that if one node is transmitting the data, then other will not transmit the data. So for the multiple access protocol to work, so we don't use out of band channel. That is, we use this channel both for data transmission as well as we use this channel or this link for multiple access protocol. So the multiple access protocol messages and the data messages, they both are using the same link. Okay, this is called in-band channel. Okay, so what should be an ideal multiple access protocol? So suppose an ideal or the best multiple access protocol should be one. For example, if this is a link, it is R bits. So if one node wants to transmit it, then it should use the full bandwidth. It should use the full bandwidth. For example, if this link is 12 MB, so if this node is transmitting, so so the whole 12 MB link should be available. So whole 12 MB link should be used by the node. Second is that if when M nodes want to transmit, then each nodes send at the rate R by M. That is, if there are 6 nodes, for example, and the total link bandwidth, the shared link, it is 12 MB. So 12 by 6, it is 2 MB. So each node should send 2 MB data per second. So this is mean that this shared link, it should be fairly used by all the nodes. It should be fairly used by other nodes. So that it means that it should be equally used by all the nodes. This point means that each node should have equal opportunity to use this shared medium. Okay, so it should not be that the one link is using 4 MB, the other is using 6 MB, and the other nodes they are using 1 MB per second. So this is unfair. Okay, so fair means that this link bandwidth, it should be available, it should be fairly, it should be equally used by all the nodes. So an ideal or the best case of the multiple access protocol is when a node transmit the data, then the full bandwidth is available to a node. This is the first case. And the second case is that when there are multiple nodes, then each node should equally use the link bandwidth. And third is that it should be fully decentralized. Decentralized means that there should not be, in some cases we need some coordinating nodes. We will discuss about it, but that one is good which don't have the coordinating nodes. And for that protocol is better which don't use the clocks. For some protocol we will discuss that the clock is necessary. The synchronization, the clocks are used. So if the clocks are used, then the synchronization of the clock is also necessary. Okay, and the fourth point is that it should be simple. We will discuss about these points again when we finish all the protocols. Okay, so up to now we have discussed two types. There are two types of links: point to point and broadcast, or shared medium, or multiple access medium. Okay, so we discussed that this both have advantages. Okay, so if the if the distance is limited, then we should use the point to point. Okay, if there are less number of nodes and the distance is minimum, it limited, then we should use point to point. If the nodes are distributed over large area, okay, and there are many nodes, then we should prefer to use the shared medium. Okay, so then we discussed that if we have multiple access link or the shared link, then the main challenge is that how this shared medium is used by all the nodes. Okay, so for this purpose we need multiple access protocol. Okay, so what should the multiple access protocol achieve? So these are the objectives they should achieve. So that multiple access protocol will be better, which achieve all these four objects. And we will discuss some multiple access protocol. Say some protocol achieves this one, some protocol achieve this one, some protocol achieve this one, some protocol achieve this one. Okay, so we will discuss about it. Okay, so now we are going to discuss multiple access protocol. These are also called MAC protocols. Okay, so all the multiple access protocol that are available in the literature, they can be classified into channel partitioning, random access, and taking turns. These are the three types of protocols. So all the protocols, they can be categorized into these three categories. Okay, so let's us discuss first and then we will discuss it. The first multiple access protocol that is we will discuss, it is called FDMA. It is called FDMA. FDMA means frequency division multiple access. What is it? Is frequency division multiple access protocol. We know that, for example, this is a link, a channel. Okay, okay, suppose this is a shared medium or a channel. Okay, so okay, this is a channel. Okay, suppose this is the a channel. So we know that when the channel is transmitting the data, so it supports certain frequency. Okay, suppose it is transmitting the data between 100 megahertz and 160. Okay, so the channel spectrum, it is from 100 megahertz to 160 megahertz. This is the frequency bandwidth. Okay, so this channel spectrum, it is divided into frequency bands. For example, this channel, it is transmitting the data from 100 megahertz to 160 megahertz. So it is divided. Okay, it is divided into frequency bands. For example, from 100 to 109, this frequency bandwidth is used by F, node F. Similarly, from 110 to 119, it is used by node E. From 120 to 129, it is used by node D. From 130 to 139 megahertz, it is used by node C. From 140 to 149, it is used by node B. From 150 to 160 megahertz, it is used by node A. So this whole bandwidth frequency spectrum, it is divided into 6 frequency bands. So F node will transmit the data from 100 megahertz to 109 in this bandwidth. Okay, so node E will transmit from 110 megahertz to 119 megahertz and so on. So it means that each one is equally using its the whole link. Why? Because if this from 100 to 160 megahertz, it is about 60 megahertz bandwidth. So suppose this 60 megahertz bandwidth, it is equal to 60 MB. So since each node has 10 megahertz, so each node can send 10 MB data. So this 60 MB bandwidth, it is divided among the 6 node A, B, C, D, F equally, because total link bandwidth is 60 MB and each node is transmitting the data at 10 MB per second. Okay. So each station is assigned fixed frequency. For example, A is assigned to always sends from 150 the data on the frequency bandwidth from 150 to 160. B will be sending the data from 140 to 149. So, okay, so each station is assigned fixed frequency bandwidth. And who assign it? It is basically assigned by centralized node. It is assigned by centralized one. There is centralized authority who assign it. Okay, for example, if you are using the cable media, the cable, so the cable operator assign it. Okay, so what is its disadvantage? For example, you can see that node D, C and A, they are transmitting the data, so they are using this bandwidth. But node B, it is not transmitting the data, then this bandwidth is useless. It is wastage. This bandwidth is wasting. Why it is wasting? Although this A node, it is transmitting 10 MB per second data, but the A node has 20 MB data. It is receiving 20 MB data per second. It wants to transmit 20 MB data, but it cannot transmit 20 MB because its frequency bandwidth is 10 megahertz. So it can only send the data up to 10 MB per second. But this bandwidth, it is available, this frequency is available because the B is not transmitting the data, but A cannot use it because they are fixed assigned. Okay, and even if it want to use, then it has to use it, it has to tune the hardware, so it has to change the hardware, so that's why it is difficult. Okay, so where it is, for example, here in this example, we have 6 nodes A, B, C, D, F. Okay, and 1, 3, 4, they are sending packet. For example, A, C, D, they are sending the data. B, E, F, they are not sending the data. So B, E, F, they are available free. Okay, so this is it is called FDMA. Okay, so FDMA, it is also centralized fixed partitioning, because someone centralized entity or authority, it assigns the frequency bandwidth to each and every base station. So the FDMA, it basically divides the channel spectrum into frequency bandwidth. Each node is assigned a fixed bandwidth, frequency bandwidth, and that node can use only that frequency bandwidth at a time. Okay, so this is the FDMA. Okay, next we are going to study another protocol. It is called TDMA, or it is called time division multiple access. Time division multiple access. Okay, what does it mean? In TDMA, how the whole bandwidth, this 60 MB per second data, this whole bandwidth, this whole channel is available. It is first used by A, for example, for 5 seconds. For first 5 seconds, it is used by node A. In the next 5 seconds, it is used by B. The whole bandwidth is used by B. In the third 5 seconds, in the third slot, it is used by node C. In the fourth slot, it is used by D. The fifth slot, it is used by E. And at the fifth slot, it is used by F. Okay, by F. So when all have finished, now again it will be used by A for 5 seconds. So you can see that we have time slot. We have time slot, 5 second time slot, and each one is using in its time slot. For example, this is A, it is using in the first slot, B is using in the second slot, C is using in the third slot, D is using at the fourth slot, E is using at the fifth slot, and F is using at the sixth slot. And when all they finish, then A will use in the seventh slot. In the seventh slot, it will be used by A again. So again, it will start from A, B, C, and so on. So you can see that the access to channel, it is in round. First it is used by A, then B, then C, then D, then E, then F. When they are finished, then again it is used by A, B, C, D, and so on. So the channel is used in round. And each station gets fixed length slot. For example, A is getting for 5 seconds, so B will also get for 5 seconds, C will get for 5 seconds, D get for 5 seconds, E get for 5 seconds, and F get for 5 seconds. Then again A will get for 5 seconds, B will get for 5 seconds, and so on, so on. Okay. So in the TDMA, the access to the channel, the channel access, the channel use, it is in rounds. That is, first is used by A, then B, then C, then D, then E, then F. When it is finished, then again it is used by A, then B, and so on. And each station gets fixed length slot. That is, it is using, A is using for 5 seconds, B is using for 5 seconds, C is using for 5 seconds, D is using for 5 seconds, E is using for 5 seconds, F is using for 5 seconds. Then again A is using for 5 seconds, B is using for 5 seconds. Okay. So suppose when A gets its round, its turn, then A is sending the data for 5 seconds. So the whole bandwidth is used by A. When A has finished, then it is the turn of B. But B doesn't have data. So this channel will be free. This channel will be free. So unused slot, it goes idle. So if B has turn and B is not sending the data, okay, then this channel will be idle. It will be free. So it cannot be used by other C or D that we have to data to send. So it will not be, because each channel has its own slot, whether to use or whether to not used. So this is the example that we have used. This channel is used by using the TDMA algorithm by node A, B, C, D, F. Okay. So again, this TDMA mechanism is centralized. Why centralized? Because there is a external entity who assigns this time slot, that this link should be used by A, B, C, D, and when A should be used, so A should use in the first turn, B should use in the second turn, C should use in third turn, and so on and so on. So when it is finished, then the A will get turn again. Okay, and for how much time? So it is also assigned by the centralized entity. Okay. So we can see that what is an ideal algorithm? The ideal algorithm is one. When a node wants to transmit, it can send at full rate. So you can see that in the FDMA, the node cannot send at full rate. The full rate is 60 MB, but the node is sending 10 MB per second. 10 MB per second. So it means that the FDMA, it doesn't meet this requirement. The FDMA doesn't meet this requirements. And the TDMA, it meets this requirement. You can see that when A gets started, then it is using the full bandwidth. So A is achieving the first objective. The A is achieving the first objective. Okay. Similarly, you can see that the second objective of an ideal multiple access protocol is what? That when M nodes want to transmit, if there are M nodes, then each node should send at the rate of R by M. That is, each node should send equally on the link. Okay, so you can see that in FDMA, okay, if there are 6 nodes, so this channel is used by equally. It is used to equally. So the FDMA achieves the second objective. The FDMA doesn't achieve the first objective, but it achieves the second objective. Okay, and the TDMA, it achieves the first objective as well as the second objective, because you can see that this channel is used by A, B, C, D, F, and each is using for 5 seconds. So each gets equal use of the channel. Okay. So now we are going to discuss random access MAC protocols. Okay, so how it works and how it is used. Okay, so what is mean by random access protocols? Let's discuss. We discussed another random. This is the random access protocol, which is called Power or unslotted Aloha. It is called Power or unslotted Aloha. And what it means? What does it mean? In pure or unslotted Aloha protocol, it is totally decentralized. It is very simple. How it is simple? When frame arrives, when the frame arrives, okay, so it is transmitted immediately. It is transmitted immediately using the full bandwidth, using the full bandwidth. So therefore, it is simple. And there is no synchronization of the clock. You can see that in the TDMA, each node is assigned. In the TDMA, each node is assigned a time. So each node should have clock. Each node should have a clock. And their clock should be synchronized. For example, if this node is assigned to use for 5 seconds, for the first 5 seconds, okay, then after, then it will use, for example, the time start at 0. So from 0 to 4 seconds, up to first 5 seconds, it will be used by A. And the second 5 seconds, it will be used by B. In the third, C, D, E, F. Then at the 7th 5 seconds, again it will be used by A. So if their clocks are not synchronized, for example, if it is at 5 o'clock here, and it is 5 o'clock and 5 minutes at B. So A is the 5 o'clock time, it is the node, the link is available by A, it should be used by A. Okay, but if there is a time of 5 and the A has 5 o'clock and B has the time 5 minutes past 5 o'clock. So, and the B has to use the link at 5 at 5 minutes past to 5 o'clock. So both will use the link, and when both use the link, then their data will collide. So if the clocks are not synchronized, then there will be collision, there will be misinterpretation. So in the TDMA, the disadvantage is that the clock synchronization is needed, but in the FDMA, the clock synchronization is not needed because there is no use of clocks, there is no use of timing. So similarly, in the pure Aloha, or it is called unslotted Aloha, when the frame arrives, so it is transmit immediately and using the full bandwidth. So it is very simpler, and it is no synchronization is needed because it doesn't depend on the timing, okay, not the slots, but it will has higher collision probability. It will have high collision probability. It is because if two and more than two nodes they transmit the same time, then their collision will occur. There will be collision. Okay. So another disadvantage of this pure Aloha is that, for example, this is the node green one. It started packet transmission I frame. Okay. Suppose this is started, and at this time another node it start its own frame transmission. You can see that when this frame transmission start, the yellow one, so the green one is last portion is receiving, is transmitted. So these are overlapping. So overlapping means that these two signal, they will be on the same time on the same link. So they will be colliding with each other. They will collide with each other. If they collide with each other, so they will last. Although you can see that this whole portion of the packet is received, only this portion is collided. When this portion is collided, then the packet will not be completely received because this is a complete packet. So this portion will be lost. When this portion is lost and this portion is received, then this received portion will be also lost, will be discarded, because when the whole packet is received, it is necessary to receive the whole packet, and since the packet, some part of the packet is not received, then the whole packet will be discarded. So this is the disadvantage, that you can see that a large portion of about 80% of packet is received, only 20% is left, but the remaining 20% it collides with another frame. Okay, so this the 80% traffic, the 80% of the traffic, the packet that is received, it will also be discarded. So this is the disadvantage of pure Aloha. To avoid this disadvantage, So this is the efficiency formula for pure Aloha, and it is about 0.18%. Okay. So we have another protocol to improve the pure Aloha to avoid this problem. Of the pure Aloha, we have another protocol that is called slotted Aloha. Slotted Aloha. Slotted Aloha, its assumptions are: number first, that all frame they are of same size. All frame they are of same size. That odd node they will transmit the data of the same packet. The packet size will be same. And the time is divided into equal size slots. Okay, there are time slots. Okay, so the nodes they can start to transmit only in the beginning of a time slot. In the beginning of time slot. So if a node has a data and it is in the start of a slot, then the data can be transmitted. Then it can start transmission of data. If it is not in the start of slot and not in the beginning of a slot, then it will wait for the next slot. Okay, so it means that the time slot is needed. So time slot needed, then they needs the clock synchronization. So the clock synchronization is needed. As in the TDMA, the clock synchronization is needed. So here in the slotted Aloha, the time the nodes should be synchronized. So if two or more than two nodes transmit in slot, then all nodes detect collision. So we will discuss it. Suppose I would like to explain it through an example. Suppose this is the time slot, this is the timing. Okay, this is the timing. Suppose this is the slots, this is the first slot, this is the second slot, this is the third slot, this is the fourth slot. So these are the slots 1, 2, 3, 4, 5, 6, 7. Okay, so suppose these are nodes, node 1, node 2, node 3. So suppose node 3 receives the data from upper layer. So node 3 wants to transmit the data. So since the node 3 receives the data in the beginning of slot, the node 3 it receives the data in this slot. And when node 3 receives the data, so it is in the beginning of the slot. So it will start its data transmission. And the packet size is decided so that the whole packet is received in this slot. Whole packet is received in this slot. Okay. So when this packet node 3 start transmission, suppose at this time node 1 also receives the data for transmission. So node 1 it receives the data, but node 1 cannot transmit the data. Why? Because it is not in the beginning of this slot. Because node 1 receives the data in this slot, but it is not in the beginning. It is not in the beginning. If it is not in the beginning, then it will not transmit the data. It will wait for the next slot. So node 1 will start its data transmission in the next slot. So the next slot is this one. So S means successful. In this slot, the node 3 data is transmitted safely. It is transmitted and other nodes are not transmitting. So it means that this data will be received correctly. It will be received without collision. So it is safe. Now suppose the E node transmit the data, it is also safe. It is not E. E means free, but it is not empty. But here this slot is not empty because it is transmitting the data. Now suppose this node is at this slot, node 1 and node 2, they both receive the data and they both find that they are in the beginning of the slot. So they both will start transmission. When they both start transmission, so their signal will be collide with each other because both nodes cannot transmit at the same time. So there is a collision. Similarly, in the third slot, suppose the node 2 start transmission data and the other nodes are not transmitting, so this data packet will be received correctly. Okay. Similarly, here node 3 it receives the data in this slot, but in this slot it receives the data at this time. So at this time it is not in the start of this slot. It is not in the beginning of this slot, but it is in the middle. So this packet, so it will wait for the next slot. Okay, so you can see that all frames, all the packets, they are of same size. You can see that here all packets, they are of the same size. Okay, and there is time slots. Okay, okay, you can see that slot number 1, slot 2, slot 3, slot 4, slot 5. Okay, nodes start to transmit only slot beginning. They can start to transmit the data only at the beginning of a slot. If it receives the data in the between or at the end of the slot, then it will not transmit the data, but it will wait for the next slot. Okay, so their nodes are synchronized. So it means that since they are using the timing, so all the nodes, they should be synchronized. So the clock synchronization is needed. If the clock are not synchronized, then there will be problem in the timing. For example, at node 3 it is 5 o'clock, and in node 2 it is 6 o'clock, and at node 1 it is 5:30, so it will not work. Okay, so clock synchronization means that node, so if it is 6 o'clock at node 3, then it should be exactly 6 o'clock at node 1 and node 2 and node 1. Okay, so if 2 or more nodes transmit in slot, then all nodes detect collision. You can see that when here node 1 and node 2, it receives the data in the beginning of slot, in this slot. So it is in the beginning of this slot, so they will transmit the data. So when they transmit the data, both nodes start transmitting data, they will collide with each other. Okay, so when node obtain fresh frame, transmit in the next slot. What does it mean? That if the node obtain a frame and it is not in the beginning of a slot, for example here it is not in the beginning of slot, then it will wait for the next slot, If no collision, the node can send new frame in the next slot. If the collision, then the node retransmit the frame in subsequent slot. Okay, for example, you can see that here node 1, node 2, when they start transmission at the same time in the beginning of this slot, third slot, so they collide with each other, then they will wait. Okay, they will wait, but here when they start the transmission in the next beginning, so they will decide random probability. For example, this timing is this probability is higher, so it will start its transmission there, and then node 1 probability is low, so it will wait for the next next slots. Okay, so this is the working of slotted Aloha. So you can see that. So if there is a collision, then it will be in the start. The whole packet will collide. Okay, so it is not in the case, for example, here that node 3 is transmitting the data and node 1 receives the data at this time. So node 1 is not transmitting the data. But in the pure Aloha, node 1 will start transmission. So node 1 start transmission, then this packet and the node 1 packet, node 3, the packet of node 3 and node 1, they will both lost. Okay, so the slotted Aloha avoids this situation. So the slotted Aloha, it has lower probability of packet collision. So what are the advantages of slotted Aloha? Single active node can continuously transmit at full rate. For example, when node is transmitting the data, so it is using the full bandwidth. Okay, the full bandwidth is available. It is highly decentralized because there is no single authority who is assigning that which node should transmit at which time. Okay, so there is no, so it is working decentralized. Everyone is operating from its own perspective. There is no a single external entity that who controls that which nodes should transmit at which time. It is simple. But its disadvantage is that the collision probability is higher, because you can see that when in this slot, node 1 and node 2, they both receive the data in the beginning of slot, and then when they start when they both start the packet transmission, then they collide. and sometime we have idle slot. For example, this slot, no one is transmitting, and in the beginning node 3 receives the data, but node 3 cannot transmit. Why? Because it is in the beginning, it is not in the, it is in the middle, it is not in the beginning of the slot, it is in the middle, so it will not transmit the data. So this whole slot, it goes idle, it goes empty. Nodes may be able to detect collision and less than time to transmit the packet, because when node 1 and node 2 they start transmission in the beginning of a slot, so in the beginning of slot we can detect the packet collision. Okay, so that another disadvantage is that since the timing is used, so the clock synchronization is needed, that the node 1, node 3, and node 1, node 2 and node 3, their clock should be synchronized. If their clock is not synchronized, for example, if it is 5 o'clock here and it is 5 minutes past 5 o'clock and it is 4 minutes past 5 o'clock, so then they will have confusion, there will be confusion, then there will be packet collision. Okay, so slotted Aloha efficiency, it is on the long run, this is the formula. Okay, so its efficiency is about 0.37, but in the pure Aloha the efficiency is 0.18. so you can see that the slotted Aloha, it improves the efficiency up to 0.37 percentage. Okay, so we have discussed the pure Aloha and slotted Aloha protocols. Okay, so next we will discuss the CMA algorithm, okay, in the next video.